What if I told you the electric vehicle industry just hit its biggest breakthrough in decades, and it could change everything you thought you knew about EVs? Toyota's CEO just dropped a bombshell, a rare earth-free motor that's ready to roll by 2026, threatening to upend the entire market and break the chains of scarce, expensive materials. This isn't hype. This is a revolution in motion, and you need to hear it now. Beneath the blinding lights of the Tokyo Auto Salon, something unthinkable was unfolding. No teaser campaign, no social media countdown, just a single man, Koji Sato, CEO of Toyota, stepping onto the stage with a blueprint in hand and a calm, seismic message that sent shockwaves through the global auto industry. We no longer need rare earths to power electric vehicles. Not we hope to, not we're working on it, but we already did it. A rare earth-free EV motor, real, production-ready, and rolling out in Toyota's 2026 lineup. The room went still. No applause, no smiles, just silence. Because in that moment, everyone watching understood what had just happened. The rules of the game had changed. EV suppliers in Europe panicked. Auto analysts in Detroit scrambled to confirm. Wall Street algorithms tripped over themselves. In under 30 minutes, Tesla's stock dropped 4.1%. Rivian and Lucid followed. Toyota was up 7%, its biggest single-day gain in over a year. But the spike wasn't just about market share, it was about control. For the first time in decades, an automaker had severed its dependence on the most strategically vulnerable supply chain in tech, rare earths. Behind that simple announcement was a truth far more dangerous, one that governments, militaries, and energy alliances had been whispering about for years. Rare earths weren't just scarce, they were a geopolitical weapon. For decades, rare earth elements like neodymium were treated as technical necessities, ugly but unavoidable. They power permanent magnet motors which dominate the EV market for their unmatched torque and efficiency. No one dared challenge them. Every major car maker, Tesla, Ford, Hyundai, BYD, relied on the same fundamental recipe, a recipe written in Chinese because 87% of global rare earth processing is controlled by China, not just mined, but processed. That means even if the US, Australia, or Canada finds new rare earths in their soil, they still need to ship it to China for refinement. That's not a market, that's a monopoly. And it's a monopoly that's growing more volatile by the day. Since 2020, rare earth prices have surged over 230%, spurred by trade tensions, export controls, and rising EV demand. The US Pentagon labeled the dependency a critical vulnerability. Japan called it an economic risk. The EU called it a sovereignty crisis in slow motion. This was the trap. Everyone knew it. No one escaped it until now. What Toyota just revealed isn't just a clever workaround, it's the engineering equivalent of slipping out of handcuffs while the world wasn't looking. And the secret? Ferrite, common iron oxide, cheap and abundant, a material engineers once dismissed as too weak for high-performance EVs. But buried inside Toyota's advanced powertrain lab, a silent revolution had been brewing for 8 years. Using ferrite wasn't enough. The challenge was to make it sing. Toyota's engineers redesigned the magnetic circuit from scratch. Every coil, every stator tooth. Then came a breakthrough, a proprietary iron-based alloy tailored through thousands of AI simulations to find the perfect balance between conductivity, temperature tolerance, and magnetic flux density. They didn't just remove neodymium, they replaced it with something new. The result is a motor that's within 3% efficiency of traditional rare earth models but at 1/5 the cost. And it isn't limited to concept cars or test benches. This motor can be produced on existing lines using minor modifications to Toyota's current hybrid and EV assembly system. No billion-dollar factory overhaul, just a software update, a tooling swap, and go. In engineering terms, it's clean. In strategic terms, it's decisive. Because now Toyota holds a key no one else does: independence. Not just from one country, but from a global tech ecosystem addicted to fragile supply chains and difficult extraction methods. This isn't just a story about cars, it's a story about autonomy, leverage, and timing. And Toyota picked the perfect moment to strike. Just as governments were pouring billions into rare earth mining subsidies, just as rival automakers were locking in long-term supply contracts, Toyota stepped out and said, "We don't need it." And the world froze. What else have they been hiding? How long have they known this would work? What happens when other automakers try to catch up and realize they can't copy the alloy or the patents or the 8 years of internal data behind it? Because this isn't just a new motor, it's a decisive move. And here's the part no one saw coming. The breakthrough wasn't built on rare earths at all. It came from a material the industry had written off, something so common, so overlooked, it bordered on laughable ferret. They said it couldn't be done. That ferret magnets, cheap, abundant, crude, would never match the power of neodymium. That rare earths were the cost of admission to the EV race. But behind closed doors at Toyota's advanced powertrain lab, the rules were rewritten. In a climate-controlled facility outside Nagoya, engineers stood around a humming prototype that, honestly, shouldn't have worked, and yet it did. The key was heat. Ferret magnets typically break down under high temperature loads, making them, pretty unreliable for the punishing demands of electric propulsion. But Toyota's team cracked the code. Using a ceramic nano-coating process adapted from aerospace technology, they stabilized ferrite performance up to 180 degrees Celsius, a threshold once thought impossible. Suddenly, what was once a lab curiosity became roadworthy. But stabilizing ferrite wasn't enough. To replace rare earths outright, Toyota needed torque, and lots of it. That's where the magnetic circuit came in. They didn't just redesign the motor, they reimagined the field lines themselves by reshaping the magnetic flow path using AI-driven coil saturation modeling. They turned a low-density material into a high-efficiency system. Traditional rare earth motors rely on brute magnetic force. Toyota's relies on precision geometry, a difference of philosophy, not just chemistry. Cooling presented the next barrier. In conventional EV motors, heat disperses via simple liquid jackets or passive fins, but this motor borrowed from jet turbine tech, using an induction-cooled rotor with micro-channel heat exchangers, a system derived from high-performance alternators. They managed to slash core temperatures by 22%, keeping performance stable across aggressive driving profiles. Even the copper wiring got an overhaul. Instead of single-layer windings, Toyota developed a dual-layer, counter-twisted copper layout. That meant faster energy transfer, tighter electromagnetic field generation, and denser torque curves, all while fitting inside a motor casing 15% smaller than its predecessor. And finally, the brain, the inverter. Off-the-shelf units couldn't handle the low field strength of ferrite magnets, so Toyota built one from scratch, a custom silicon carbide module with predictive field compensation, able to dynamically reshape current pulses in real time. The result is a system that mimics the performance of neodymium without needing a single atom of it. But here's the real twist. This wasn't an overnight miracle. It was a deliberate long game, 8 years in the making. While headlines obsessed over battery cells and lithium breakthroughs, Toyota quietly invested heavily into next-generation electric motors. It wasn't flashy. It wasn't public. But it was strategic. Internal memos reveal the intent clearly: build for disruption, build for independence, build for when the world changes. This wasn't just engineering foresight, it was strategic planning. Toyota saw the writing on the wall long before it was widely acknowledged that critical minerals were a potential vulnerability, and that relying on one dominant processing source was a risk. So, while rivals chased range and battery density, Toyota drilled into motor independence. They mapped out every vulnerability in the EV supply chain, from mining and magnets to shipping bottlenecks, and began removing dependencies one by one. This wasn't about publicity. This was about resilience. Japan's government quietly backed this play. Through grants and tech subsidies, the Ministry of Economy, Trade and Industry coordinated with Toyota on material security. Because for Japan, this wasn't just about selling cars. It was about ensuring that when geopolitical tensions rose and trade routes faltered, the nation's largest automaker wouldn't flinch. And now the moment has arrived. Rare earth prices have spiked, export restrictions have tightened, and the EV giants, the very companies that once led the pack, are now exposed. Tesla's prized motors still contain trace neodymium. Its factories can innovate around form factors but not around fundamental materials. The next-gen Roadster, the Cybertruck, they still need rare earths, which means they still need that supply chain. BYD, despite massive vertical integration, still runs on permanent magnet motors sourced from